This video is going to examine the basics of how to use OscerSketch. When you open OscerSketch, you'll see this menu up here. The most striking thing, of course, is a list of the common elements along the top. These are the elements most commonly found in first semester organic chemistry. Most compounds, of course, are based upon carbon, so we click on C to draw a carbon atom. We also need a bond, and down here with a single bond is lit. So we're going to draw single bonds. And notice it says multiple clicks cycle through bond order. It means if you click on the bond a second time, it'll turn it into a double bond. So I'm just going to click, I'll get a methane, but I want to draw a bond. So if I click on it down and hold the mouse down and drag, what I'll do is I will draw out additional atoms. I'm doing this by clicking and dragging. Now what if I really wanted one of those atoms to be an oxygen? Well, I can click on the oxygen and then click on the CH here and it'll turn it into the oxygen. Now a word about hydrogens. Atoms like oxygen, of course, will have one hydrogen on it because oxygen forms two bonds. The program automatically puts that in. It also automatically puts in the hydrogens on the carbons if it's an end atom. So CH3 is automatically labeled as hydrogens, but the internal ones, to save space, make the drawings look simpler, we just simply assume that that's a CH2. Now let's turn this to a carboxylic acid. I want now a carbonyl here. Well, I can do this by going to the double bond. Oxygen is still lit. I click on the carbon and simply draw up, and there's my carbonyl. Now this hydrogen, I want to talk about a reaction of this hydrogen. So let me click H, and I'm going to explicitly draw in the hydrogen atom. Oops, I still was on double bond. That's a mistake. So I'll go back to single bond, and I will click and turn that into a single bond. So let's do a reaction. I want to do the reaction of this acid. What is it? Butanoic acid with a base. Let's say methylamine. So I need a nitrogen. Okay, so you hit it. That's first it draws ammonia, but now I want to put a methyl group on it. And so I simply draw out. So here I have methylamine reacting with this acid. So what's the product going to be? Of course, what's going to happen is the nitrogen lone pair is going to reach out and grow that hydrogen. If I want to show the lone pair, I could do that just for fun. If you click on the nitrogen, it'll automatically put in a lone pair. Now let's do a reaction. So what's the product going to be? Well, the product is going to be the nitrogen is going to steal the proton off the oxygen, and you'll get an O-. And so let's draw that out. Now, I could just redraw the whole thing over here, but there's a shortcut. You come up here with a 1 to 2 key. This means it takes one molecule and makes two. It's duplication. So click here. It generates another molecule, turns blue, and I can go over here. But this is going to be my product, so I don't want that hydrogen on there because the nitrogen has taken it. So I erase the hydrogen. It just draws it back in, so I got to tell it it's a negative charge. So I click on the minus sign up here, and it goes to the negative charge. Now if I want to get rid of that negative charge, I click on positive, and it'll get rid of it, but I need the negative, so let's put it back. Okay, now the other product, of course, is the amine, and so I'm going to duplicate the amine. Now I got to get rid of that lone pair because it's used up. The way to get rid of the lone pair is go back to the lone pair button and click. It'll add 2 electrons, it'll add 2 electrons, but then it'll go away. So it cycles through 1 lone pair, 2 lone pairs, 3 lone pairs, none. Now I need to make it a cation though, pick up another proton. There it is. So that's the ammonium cation. Now if you really wanted a plus sign in there, you can go up here, you can put a plus in the blank. You can say I want to add some text. Hit the TX key here, that means text, and you can put in that plus between the letters. I often don't do that, I just kind of assume it, but if you like to have it, you can. Now, what else can you do? Well, in organic chemistry we like to draw curved arrows. This up here is the curved arrow key. Click it and it says draw a curved arrow. Now read the instructions. Click to start on an atom or bond, click to a trajectory point, then finish with a final click on an atom or a bond. Curved arrows are red in color. So how does this work? Well, it means you want to start an arrow where the lone pair is, and you click at a point in space, then it's going to attack the proton, so it's going to draw a nice curved arrow this way. But now you also have to show what happens to the bond between the oxygen and the hydrogen. It's going to become a lone pair on the oxygen. So you draw another curved arrow, click on the bond, a point in space, and then back onto the oxygen, and it shows you the total movement of the electrons. So this is a complete reaction, all drawn out. Now, if you're in solving a problem with this, there's going to be a save button up here on the top. Right now we're using OscerSketch on the login page, so it's not there. What you can do, though, you can save it, so when you reopen the program, this same reaction will be there. You can also submit it, and when you submit it, what that does is it sends it to the computer, and if you're in lecture, it means the instructor can look at what you submitted. But for now, we're simply going to end this little video having covered the basics of how to use the program.